x squared minus y squared equals to 1. In contrast, the circle, of course, the unit circle has equation x squared plus y squared equals to 1, right? Now, in your course, we haven't really talked about hyperbolas, right? But there's a larger discussion of circles, which would include, when you change a plus to a minus, you get, instead of getting circles, you get hyperbolas, which are like these kind of things. The dotted lines are the asymptotes. They approach that, but they don't get to it. So like the hyperbola is stuck between the lines y equals plus or minus x. As it goes out here, if I did a better job drawing it, it would look more like this. Anyway, if you take this point right here, you can parameterize that point on the hyperbola by cosh t, sinh t. Because one of the things you can prove about cosh and sinh, and I'll probably let you do this in the homework, you can prove that the following identity is true. You can prove that cosh squared t minus sinh squared t is equal to 1. So you can compare that to the corresponding identity for sine and cosine, which is like cosine squared plus sine squared t equals to 1. So, and this is just the start of this. There are deep and profound analogies between sine and cosine and cosh and sinh, right? And there are also really neat formulas if you start looking at the inverse functions of hyperbolic sine and cosine, right? That's a problem you could try to solve. It's pretty tough. Like that's an algebraically tough problem. I'll probably ask that in your homework, but that'd be like a challenge problem. You see here. Trying to think what's most useful for me to say at this point. Oh, what's the first thing you do when you encounter new functions? What do you want to ask about? Like, what's their domain? What's their range? What's their graph look like? Right? So I've just given you definition of cosh, definition of sinh. I've told you a little bit about its connection, why we call it hyperbolic. It's because it parameterizes the hyperbola, just like the circular functions parameterize the circle. But we should also look at the graph of cosh and sinh, right? What do those look like? So let's look at y equals to cosh of x, which is 1/2 e to the x plus e to the minus x. We already know one point on the graph, right? What's the y-intercept? We figured out cosh of 0 is what? It's 1, right? So that means that the y-intercept of the graph is 1. And then what happens? Let's think about these terms. What happens to e to the x as you go out to infinity this way? What happens to the exponential? It gets bigger and bigger and bigger and bigger. What happens to e to the minus x as x gets really large? This gets smaller and smaller and smaller and smaller, right? So like the e to the x term dominates this formula as x gets large. So essentially this just looks like e to the x over 2. If you go like that way. So it basically looks like an exponential. In the other direction, if you take x large and negative, what happens? Well, e to the x gets really small for large and negative inputs. But what about e to the minus x? Well, for large negative inputs, this is giving you exponential of a positive thing, which gets larger and larger. So as x goes to minus infinity, this other term dominates, and it again looks like an exponential. So essentially, this looks like kind of like the graph of x squared plus 1, but what I failed to capture here is that both sides of these are exponential growth. I mean, I'm not doing them justice. They're like super steep, much steeper than like x squared plus 1. And in contrast, the sinh, its y-intercept is 0. it's got exponential growth like that because the, you know, e to the x term dominates over there, and then e to the minus x term dominates over here. So this first term is 0 over here, goes to 0, whereas that one dominates, so it goes to minus infinity. So basically, this looks kind of like a cubic. But again, I'm not quite doing it justice because these are both like exponential growth, but this is cosh and sinh in a nutshell. So you can tell me, what's the range of cosh? I heard 1 to infinity. 1 is included, right? Exactly. You got it. What's the range of sinh? Yeah, minus infinity. It's everything, right? And that's exactly what you need for this hyperbola, by the way, because notice, like, if you study this more carefully, this closest point to the origin, where it turns around, that's actually 1 unit. So, like, you need the formula for x to get at the smallest to be 1, and then to go on and on. That's what cosh does. Sinh, on the other hand, gets as negative as you want, or as positive as you want, going up and down. That's what you want for the y. But anyway, giving 2 formulas as a function of time to describe a curve, this is called parameterizing a curve, right? Now, some people think this should be a standard topic in pre-calculus, but I think most of those people haven't taught pre-calculus, right? Because I think you guys have enough going on in here without adding, like, how do you parameterize curves? But it is, technically speaking, just pre-calculus. So you don't need calculus to parameterize curves. It's just an algebra problem. All right. But anyway, you know, I'm not going to like put that in your homework. Your homework will be mostly like solving the problems like I solved for you guys today. And then there'll probably be like a token, find the inverse function, you know, like we did before I put this stuff up on the board. And then there'll be like a problem or two exploring the properties of cosh and sinh. All right? Now, I would be remiss if I didn't misbehave a little bit here. And this is just a comment. Cosine theta, in fact, you can write like this. In sine theta, in fact, you can write like this. So the analogy, it's even deeper. It's even deeper than I can really show you in here because, of course, this is out of place here because you don't know sine and cosine, right? But in fact, there's formulas for sine and cosine in terms of what are called imaginary exponentials. And you see the pattern, right? I mean, it's exactly the same pattern as the cosh and the sinh. So, in fact, this is cosh of I theta. So there is a literal transference between the cosine function and the cosh function if you take a complex perspective. And the same is true for this. This is minus I sinh. Well, anyway, this is a sinh of I theta. I forget if it's plus or minus. I got to think through it, and I don't want to do that right now. But okay, so we've got like a minute left, right? So you guys wanted bonus points, and I did promise heaven I'd do this. So. Man, I'll tell you what, when I was in Christian school in the 5th grade, if my teacher had handed out the Mad Minute and one of us had said what you just said, we would have gotten in so much trouble. we would have been to like, I've been to like the principal's office. I would probably got paddling. I don't know.
I literally don't remember. All I know is
Go. You got a minute. It's a Mad Minute. Time is on the line. All right, I will start the minute since we didn't have a pencil. I will start it. Ready, set. 5, 4, 3, 2, go. No calculators. I see you. I guess I should probably turn off the video.